Volcanoes. They inspire awe and fear. These fiery mountains remind us of the immense power hidden within our planet. But what are they exactly? How do they form and why do they erupt with such violence? Imagine a world of fire and molten rock. This is the world beneath our feet. Deep inside Earth, temperatures soar, melting rock into a flowing substance called magma. This magma seeks a way out, rising towards the surface. When magma reaches the surface, we call it lava. Lava flows out of openings called vents, creating cones of cooled lava and ash. These cones, built up over time, are what we know as volcanoes. Volcanoes are not just destructive forces, they are also creators. Volcanic eruptions have shaped our planet for billions of years, forming islands, mountains, and even our atmosphere. To understand volcanoes, we must journey into the heart of a volcano. This journey takes us deep beneath the Earth's surface, where the true power of a volcano lies hidden from our everyday view. Beneath the surface lies a complex system of chambers and conduits that channel magma upwards. These underground pathways are the lifelines of a volcano, guiding molten rock from deep within the Earth to the surface. The magma chamber is a vast reservoir of molten rock. This chamber is like a giant underground lake, filled with molten rock that is under immense pressure. It lies several kilometers beneath the volcano. The depth of the magma chamber can vary, but it is typically found between 1 to 10 kilometers below the surface. Think of it as a giant underground cauldron, constantly bubbling with molten rock. The intense heat and pressure within the chamber cause the magma to remain in a liquid state, ready to be pushed upwards. From the magma chamber, a network of conduits or pipes carry the magma upwards. These conduits are like the arteries of a volcano, transporting the molten rock to the surface. These conduits can extend for miles, connecting the magma chamber to the surface. They can be narrow or wide, and their paths can be straight or winding, depending on the geological structure of the volcano. The vent is the opening through which magma erupts onto the surface. This is where the molten rock, now called lava, finally escapes the confines of the Earth. Vents can vary in size from small cracks to massive craters. Some vents are barely noticeable, while others can be large enough to form entire volcanic craters. They are the gateways through which Earth releases its fiery breath. When a volcano erupts, it is through these vents that lava, ash, and gases are expelled with tremendous force. The cone is the most visible part of a volcano. This is the iconic mountain-like structure that we often associate with volcanoes. It is the mountain-like structure built up by layers of cooled lava, ash, and other volcanic debris. Over time, each eruption adds new layers, gradually building the cone higher and higher. The cone's shape and size can vary greatly depending on the type of volcanic activity and the materials ejected during eruptions. Some cones are steep and symmetrical, like the classic stratovolcanoes, while others are broad and gently sloping, like shield volcanoes. Each type of cone tells a different story about the volcano's eruptive history and the forces that shaped it. The materials that make up the cone, such as lava, ash, and volcanic rocks, provide valuable clues about past eruptions. By studying these layers, scientists can learn about the frequency and intensity of volcanic activity, helping to predict future eruptions. Understanding the anatomy of a volcano is crucial for predicting eruptions and mitigating their impact. By studying the intricate systems beneath the surface and the structures above, scientists can better understand the behavior of these powerful natural phenomena. While volcanoes can be destructive, they also play a vital role in shaping our planet. They create new land, enrich the soil with minerals, and even influence the climate. The study of volcanoes is not just about understanding their dangers, but also appreciating their contributions to the Earth's dynamic system. So the next time you see a volcano, remember the complex and fascinating world that lies beneath its surface. From the hidden magma chambers to the towering cones, each part of a volcano tells a story of the Earth's fiery heart. Volcanoes are not randomly scattered across our planet. Their distribution is linked to the movement of Earth's tectonic plates. Imagine Earth's surface as a giant jigsaw puzzle. The pieces of this puzzle are the tectonic plates, constantly shifting and colliding. Most volcanoes form at the boundaries of these plates. As plates collide, one plate may slide beneath the other, a process called subduction. The intense heat and pressure melt the rock, creating magma. This magma, being less dense than the surrounding rock, rises towards the surface, eventually erupting to form volcanoes. This is how volcanic island arcs like the Ring of Fire around the Pacific Ocean are formed. Volcanoes can also form at hotspots, areas where plumes of hot magma rise from deep within Earth's mantle. These hotspots can create chains of volcanic islands like the Hawaiian Islands. Section 4. The pressure builds, magmas rise to power. The eruption of a volcano is a dramatic release of energy, a spectacle of nature's raw power that can be both awe-inspiring and terrifying. But the process that leads to this eruption is not sudden. It's a slow and steady build-up of pressure deep within the Earth, a process that can take years, decades, or even centuries. Beneath the surface, magma accumulates in a magma chamber, a reservoir of molten rock. This magma is not static. It is constantly moving, driven by the heat from the Earth's core. As more magma flows into the chamber, it exerts increasing pressure on the surrounding rocks. This pressure is similar to the pressure inside a bottle of champagne, where the carbon dioxide gas is dissolved in the liquid under high pressure. The pressure continues to build until it exceeds the strength of the surrounding rocks. The rocks can only withstand so much force before they begin to crack and break. When this happens, the magma forces its way upwards through cracks and weaknesses in the Earth's crust. This journey to the surface is not easy. The magma must navigate through a maze of rock layers, each with its own resistance. The rising magma often contains dissolved gases like water vapor and carbon dioxide. These gases are trapped in the magma under high pressure. As the magma rises, the pressure decreases, allowing these gases to come out of solution. They form bubbles within the magma, much like bubbles form in a carbonated drink when the pressure is released. As the magma continues its ascent, the pressure continues to drop, and more gas bubbles form. These bubbles expand rapidly, increasing the volume of the magma and adding to the pressure within the magma chamber. The expanding gas bubbles create a frothy mixture of magma and gas, which is less dense than the surrounding solid rock. This mixture rises even faster towards the surface, driven by the buoyant force of the gas bubbles. As the magma nears the surface, the pressure from the expanding gas bubbles becomes overwhelming. The magma is propelled upwards with tremendous force, breaking through the Earth's crust in a violent eruption. It's like shaking a bottle of soda before opening it. The pressure from the gas bubbles builds up, and when the cap is removed, the liquid is forced out in a powerful spray. Similarly, the pressure from the gas bubbles in the magma propels it out of the volcano in a spectacular eruption. The eruption releases not only lava, but also ash, gas, and rock fragments. These materials can be ejected high into the atmosphere, creating an ash cloud that can travel for miles and affect the climate. After the eruption, the landscape around the volcano is transformed. The cooled lava and ash cover the ground, creating a new layer of rock. Over time, this new rock will weather and erode, becoming part of the Earth's surface. Life will eventually return to the area, with plants and animals adapting to the new environment. The cycle of destruction and renewal is a natural part of the Earth's dynamic system. In some cases, a new lava dome may form within the crater, marking the beginning of a new phase of volcanic activity. The process of magma accumulation and pressure buildup will start again, leading to future eruptions. Volcanic activity is a constant reminder of the dynamic nature of our planet. It shapes the landscape, influences the climate, and reminds us of the powerful forces at work beneath our feet. Magma's rise to power is a testament to the incredible energy stored within the Earth. It is a process that is both destructive and creative, shaping the world we live in. And so the story of magma's rise to power continues, a never-ending cycle of pressure, release, and renewal. Section 5, From Slumber to Fury, the eruption begins. In this chapter, we delve into the awe-inspiring phenomenon of volcanic eruptions, where the Earth's inner forces break free in a spectacular display of power and beauty. The moment of eruption is a spectacle of nature's raw power. It's a dramatic event that captures the imagination and reminds us of the dynamic forces at play beneath the Earth's crust. The once dormant volcano roars to life, spewing forth molten rock, ash, and gases into the atmosphere. This transformation from a quiet giant to a raging force of nature is both terrifying and mesmerizing. The type of eruption depends on the composition of the magma and the amount of gas it contains. Magma, rich in silica, tends to be more viscous, leading to explosive eruptions, while basaltic magma, which is less viscous, results in gentler, effusive eruptions. Some eruptions are explosive, sending columns of ash and rock high into the atmosphere. These eruptions can be heard for miles and can have significant impacts on the climate and environment. Other eruptions are effusive, with lava flowing gently out of the vent like a river of fire. These types of eruptions create stunning landscapes and can continue for months or even years. The Hawaiian volcanoes are known for their effusive eruptions. The lava flows from these eruptions have created the islands themselves, building them up layer by layer over millions of years. During an explosive eruption, the force of the expanding gases can shatter the surrounding rock, creating a massive crater called a caldera. These calderas are often filled with water over time, forming beautiful crater lakes. Calderas can be miles wide and thousands of feet deep. They are some of the most dramatic features on the planet, showcasing the immense power of volcanic activity. Volcanic eruptions can also trigger other natural disasters such as earthquakes, tsunamis, and mud flows. The sudden release of energy can cause the ground to shake violently, leading to widespread destruction. These secondary effects can be just as devastating as the eruption itself. Mud flows or lahars can bury entire communities, while tsunamis generated by underwater eruptions can travel across oceans, impacting distant shores. Throughout history, volcanic eruptions have had profound impacts on human civilizations. The eruption of Mount Vesuvius in 79 AD buried the cities of Pompeii and Herculaneum, preserving them for future generations to study. Today, scientists use advanced technology to monitor volcanic activity and predict eruptions. Seismographs, satellite imagery, and gas sensors help volcanologists understand the signs of an impending eruption and issue warnings to protect lives and property. Despite their destructive power, volcanoes also create some of the most fertile soils and stunning landscapes on Earth. Many regions around the world owe their rich biodiversity and unique ecosystems to past volcanic activity. Communities living near volcanoes have learned to coexist with these powerful natural features. In many cultures, volcanoes hold significant spiritual and cultural importance, symbolizing creation and destruction, life and death. As we continue to study volcanoes, we gain valuable insights into the Earth's inner workings and the processes that shape our planet. This knowledge not only helps us prepare for future eruptions, but also deepens our appreciation for the dynamic and ever-changing nature of our world. The story of volcanic eruptions is one of awe and respect. From the moment a volcano awakens to the lasting impact it leaves on the landscape and human history, it is a powerful reminder of the Earth's incredible forces at work.